I want to discuss the one-period binomial put option pricing model. Now, you usually don't see a put option pricing model. Usually you see the call option pricing model, and I've done one for the call option pricing model as well. But the concept is the same. You price an option based on the concept of arbitrage. That is, you set up a portfolio that has the same return as another portfolio that you know the return of, and then they should have equal prices. So let's take a look at an example here. So for those of you who aren't familiar, a put option is an option that lets you sell at the exercise or strike price. So if the price goes down, you make money. So it's a good way to protect yourself, if you happen to own the stock. So let's take a look at this example. So we're going to assume the stock price is 26. The interest rate is 5%. The option matures in 6 months. And the strike price, that is the price you can sell the shares at, is $26. We want to find the price of the put. So in the binomial model, there are only two states of the world in the next period. So we're going to assume that prices can rise to $27.50 or prices can fall to $24.50. So let's take a look at this little tree here. So right now the price is 26 for the stock, and we want to figure out what the put option price is. In the up state of the world, the stock price goes to $27.50. What's the payoff for the put? It's the maximum of 0, or the strike price, minus the stock price. So that is, you can sell it for 26, but it's selling for $27.50, so you would be losing money here. So it just takes on a value of 0. In the down state of the world, the price falls to $24.50, and it's also the maximum of 0, or 26 minus $24.50. And in this case, it's worth $1.50, right? The stock price falls to $24.50. You can sell the stock for 26. You make $1.50. So what we want to do is we want to create a portfolio where we buy puts and sell short delta shares of the stock. So this is what the portfolios look like at time 0 and in the up state and the down state. The value in the today is the value of the put minus delta times the price of the stock. Remember, you've sold short the stock, so that's why you're subtracting it. In the up state of the world, we know the value of the put is 0 minus delta times the price of the stock. In the down state, it's the value of the put, which was $1.50, minus the number of shares times $24.50, which is the price of the stock. So the hedge ratio here, this delta, is the number of shares we must sell for every put we buy to create a riskless portfolio. For the portfolio to be riskless, the value must be the same in both states of the world. So we set the value. This is the value of the portfolio in the up state. This is the value of the portfolio in the down state. And we solve for delta. And we see that delta is minus 0.5. What does that mean? That means you're selling short a negative half a share of stock. So what you're actually doing is buying half a share of stock for every put that you buy. And that makes sense, right? If the price of the stock goes down, you should be losing money on the stock, but making money on the put. That offsets your loss. If the price of the stock goes up, you'll lose money on the put, but you'll make money on the stock. So this is going to be a riskless position. So you're going to actually be buying the stock. Now, for those of you who have a problem with, buying half a share of stock, you can just scale this up. So you can say you have to buy 2 shares of stock for every 1 put option that you buy. Or you could scale it up more. You buy 200 shares of stock for every 100 put options you buy. So, as I said before, selling short this negative amount means buying half a share for every put you buy. In the upstate of the world, the price is $27.50. So we know the put is worth nothing. Minus 0.5 times minus $27.50 is $13.75. In the downstate, where the price is $24.50, we know the put is worth $1.50 minus this 0.5 or this negative 0.5 times minus 24.50, it's also 13.75. So the value is the same in both states of the world. We've created a riskless portfolio. So the final step in valuing the put is to find the present value at time period 0 of the portfolio. They're both worth 13.75, so it doesn't matter which you take. I'm going to discount by 1.025. The interest rate was 5%. This is for 6 months, so I'm going to use 2.5%. You could, if you wanted to, use the continuous time discounting approach, but I'm just going to make it simple and use discrete time. Turns out to be $13.41. Okay, taking the equation for the portfolio at time period 0, right? That's the value at time period 0, which we found the present value of, equals the put minus a negative 0.5 times 26. If we solve for P, we get that the put option is worth 41 cents. So again, there are a couple of ways you can solve for the value of the put. You could solve for the value of the call option and use put-call parity to find the value of the put. And in fact, in the other video I did using the call option pricing model, I used these same numbers, so put-call parity would hold. And I found that, in fact, it did hold. That if you use put-call parity, if you solve for the value of the call, you could find the value of the put using put-call parity and get it at 41 cents. Okay, but here you can solve it directly. So I hope this was helpful and it gives you sort of a better understanding of how to value an option using this concept of arbitrage and creating a riskless portfolio, which would have to earn the riskless rate of return.